This video is on solid revolution. Here I have the line y equal to x, and then this graph here is the graph of y equal to x squared. And so the point of intersection here is 1, 1. And so this is the region that we want to revolve. And this time the axis of revolution is going to be the line y equal to x. So we're going to revolve this region right here around the line y equal to x, and then we'll get a solid revolution that looks like this. And to find the volume of the solid revolution, what I'm going to do is I'm going to rotate this solid revolution here 45 degrees, and then we'll get a solid revolution that looks like this, and then find the volume of this solid revolution. And so once again, this is the region here. This is the region that we want to revolve about the line y equal to x. And then when we revolve it, then we get a solid revolution that looks like this. And so to get an approximate volume for this solid right here, what I'm going to do is I'm going to slice or divide the solid here into 15 slices, and then find the volume of each slice. And so notice that for this slice right here, slice number 1, the thickness will be from here to here. And then slice number 2, the thickness will be from this point to this point, and so on. And then for the radius of the slice, I'm going to use the midpoint. And so for slice number 1, the radius will be the perpendicular distance from this point to the curve. And then for slice number 2, the radius will be from this point on the axis of revolution to the curve, and so on. And so if we do that, then here's what the calculations will look like. And so what I did here is I calculated the distance from this point to the curve, the perpendicular distance, and that'll be the radius for this number 1, and then the distance from here to here, perpendicular distance, disk number 2, and then calculate the thickness of each disk. And so the sum of the volumes of the 15 disks is about 0.0742. And so the volume of this solid revolution here is approximately 0.0742. And to get the exact answer, we have to divide this solid revolution here into an infinite number of disks. But the problem that we have here is that the axis of revolution here is not vertical or is not horizontal. So what I'm going to do is I'm going to go ahead and rotate this region right here 45 degrees, since the angle from here to here, the angle from the axis of revolution to the y-axis, this angle right here is 45 degrees. And so we rotate it 45 degrees, and then the axis of revolution will be the y-axis. And so I'm going to rotate it like this. And then the rotated region will look like this. And then the solid revolution of the rotated region will look like this. And so the next thing we're going to do is to get the volume of this solid revolution here, we're going to need the equation for this line right here, for this graph. Now the original graph is y equal to x squared. But to get this volume of this solid, we need the equation of this graph right here. For the original graph, the function is y equal to x squared. And so the corresponding parametric equations are x equal to t and y equal to t squared. And so these are the parametric equations for the function y equal to x squared. To rotate this graph right here 45 degrees, then we can use this set of formulas right here. And so x r here for rotate, and so x rotated is equal to the original x times cosine of theta minus y sine of theta. And then the y rotated will be the original x times sine of theta plus y cosine of theta. And so in this case, theta will be 45 degrees, since the angle from this angle right here is 45 degrees. And then the cosine of 45 degrees is the square root of 2 over 2, and then sine of 45 degrees is also square root of 2 over 2. But notice that x is t and y is t squared. And so these are the parametric equations for this graph. So the parametric equations for the original graph are x equal to t, y equal to t squared. The parametric equations for the rotated graph, for this graph here, is x equal to the square root of 2 over 2t minus the square root of 2 over 2t squared, and y equal to the square root of 2 over 2t plus the square root of 2 over 2t squared. But now what we need is, instead of the parametric equations, we need the corresponding rectangular equation for this graph. So once again, the parametric equations for this graph is x equal to t and y equal to t squared. And the parametric equations for this graph, the new graph, the rotated graph here, are these parametric equations. And so we do x plus y, and then we can see that this term here, they will cancel each other out. And then what's left is going to be the square root of 2 over 2t plus the square root of 2 over 2t, which is the square root of 2t. And so t is equal to x plus y dividing by the square root of 2. And then using this equation right here, in the place of t, we have x plus y over the square root of 2. And then same thing here, t is x plus y over the square root of 2. And then simplify here, we get, so multiply everything out here, we get 1/2 x plus 1/2 y minus the square root of 2 over 4 times x squared plus 2xy plus y squared. And then move everything to the left side. And then multiply everything by 4. And then we end up with this. And then rearranging the terms, or combining the terms with the x right here, then we get the square root of 2 times x squared plus 2 times the square root of 2y plus 2 times x minus 2y, and then plus the square root of 2 times y squared. And then solving for x in terms of y, then we'll use the quadratic formula. So this will be a, this will be b, and this will be c. And so here I'm using the quadratic formula. So this is minus b, so this is b, plus or minus the square root of b squared minus 4a times c. So this is c. And then dividing by 2 times a. A is the square root of 2. And then next, simplify by dividing everything here by each term here by 2, and dividing this term here by 4, and divide this term by 4, and dividing the bottom here by 2. And then we end up with this. and then multiply this out, and then we end up with this. And then notice that this term, the term 2y squared and minus 2y squared, they will cancel each other out. And then what's left is going to be minus the square root of 2y plus 1, and then plus 4 times the square root of 2y plus 1. And here we have the plus and the minus. But notice that the graph here, this graph is in the first quadrant. So we're keeping the plus instead of the minus. And so this is the rectangular equation or the rectangular function for this graph. So the graph, the function for this graph is this function. And so let's call it h of y. And now, just like before, to find the volume of this solid of revolution here, we'll divide it into an infinite number of disks. And so we'll divide the interval from 0 to the square root of 2 into n sub-intervals. Notice that this point right here, the original point right here is 1, x is 1, y is 1. So when we rotated the original graph, this point right here on the y-axis will be the square root of 2. The reason for that is the distance from the origin to the point 1, 1. The distance from here to here is the square root of 2. And therefore the distance from the origin to this point will be the square root of 2. And now let delta y be the thickness of the ith disk or the subinterval disk width. And so the radius of this ith disk will be the distance from the y-axis to the graph. This is the graph of h of y. And so the distance from here up from the x-axis up to the disk, we'll call it y sub I star. And therefore the distance from here to the graph will be h of y sub I star. And a few moments ago, we found that the function for this graph is this. And then this is, so this would be the radius of the ith disk. And so the volume of the solid would be the sum of the infinite number of disks right here, the sum of the volumes of the infinite number of disks. So it would be pi times the square of the radius times the thickness, and then with n running to infinity. And just like before, if this limit here exists, then we'll write it as the integral from 0 to the square root of 2. 0 to the square root of 2. And now let's evaluate this definite integral right here. And so here I have the square root of 2 squared. And so we get 1/2 right here. So we get 1/2 times pi, and then this expression right in here. Now to evaluate this integral, we can use what's called the u substitution method. So just let u be 4 times the square root of 2y plus 1. And then worked it out. And then evaluate it, and then it will come out to be pi over 15 times 2 to the 3/2. And then simplify a little bit, and we get pi times the square root of 2 over 60. And so this is the exact volume for this solid of revolution, which is the volume of the original solid. And then recall that this approximate answer here is when I divided the original solid into 15 slices, and we got an answer of 0.07421, and we can see that it's very, very close to the answer when we divide the solid into an infinite number of slices. And that's the end of the video.